welcome everyone again. This is your second lecture where I would like to show you some maths based on the first lecture's basic. So in order to solve these maths, you need to review the basic from the first chapter and then see the solution of these problems. I will start with a very easy problem from the book, which is 4.17, and then gradually go to more difficult maths. So let's read the question first. It says, consider the probability distribution function. So we have a probability distribution function. If you don't remember from the first lecture, probability distribution function is that function where you have x's and probabilities against all the x's and you draw it in a table. So that is called a probability distribution. So when you distribute your probabilities against all the x's, that is called a probability distribution. Now the first math is based on a probability distribution. So we have a probability distribution given. We have x's here and we have probabilities against each of the x's. Now the first question is graph the probability distribution function. I will not do it, you will do it in your own copy. Graph the probability distribution function. In order to do that, you will have to plug in the x values in x-axis and probabilities in your y-axis and then draw the graph. So shouldn't be difficult for you. For B, I will start from B, which says calculate and graph the cumulative probability distribution. If you remember from first lecture, cumulative probability distribution was f of x. So we will have to calculate f of x first and then draw the graph. In order to do that, I will use the whiteboard. So in the question, we have x's given. X's are 0 and 1. We also have probabilities given for each of the values of x's. For 0, I have 0.5. For 1, I have also 0.5. So again, these are given in your question. I'm not making this up. So the x values are given, probabilities are given. Now they have asked us to calculate the cumulative probability distribution. Cumulative probability distribution is f of x. And how did we do it? The first probability will stay as it is. So the first f of x will be 0.5. Okay, so the first cumulative probability will be 0.5 and the second one will be 0.5 plus 0.5. You have to add it backward. So this one plus the previous one, which is 1. So this is your cumulative probability distribution function. Let's go back to the question again. It said calculate and graph the cumulative probability distribution. So the probability distribution we had f of x there, but we didn't graph it. So we will graph it now. I will do it very shortly. In x-axis, we will plug in x value. So we just have 0 and 1. In y-axis, we will plug in f of x. So let's say 0, 2 here, 0.5 here. For 0, I have 0.5. will be here. For 1, I have cumulative 1. It will be, then I will have to touch these two dots. Yeah, so I just grabbed cumulative distribution function. Um, it Notice that it will always be upward sloping because my f of x will always be increasing no matter how many x's I have here, and in the end I will always get 1, so the last value will always be at the top. So it will be upward sloping and a straight line. Okay, so let's go back to the question again, the next part. So that was B. C says find the mean of the random variable x. Okay, find the mean of the random variable x. In order to do that, I would like you to like remind you the formula for expectation of x. So say this was expectation of x was summation of x times probability of x. This was the formula for your mean or expected value. And how we did it, we created another column with x times probability of x, and in the end we added all the values to get our mu. So I will do it here again. Notice that I'm doing I'm doing C. I just did B a while ago. So in C, I will create another column with x times probability of x. So 0 times 0.05 is 0, 1 times 0.5 is 1 times 0.5 is 0.5. If I add these two, I will get 0.5. So this is the mean mu. Alright. So I get my mu. I'm doing this math, although it's very easy, but I'm doing this math to show you the process so that even if we have a lot of values in x, you know how to solve it, or you know how to make the table to get the final result. So I will go to the question to see the next part of the question. D says find the variance of x. Okay, find the variance of x. Before I start it, I would like to remind you the formula of variance. Formula for variance was summation x minus mu whole square times probability of x. That means I will have to create another column. Sorry, this is just probability of x. So that means I will have to create another column with x minus mu whole square times probability of x. And then in the end, I will have to add the column to get my final result or variance. So it will be x minus mu whole square times probability of x. plug in all the values here for the first x, which is 0. X minus mu, 0 minus 0.5. 0 minus 0.5 is minus zero point 0.5. Then square it. If you square it, you will get 0.25. And then times probability of x. The probability is 0.5. So 0.25 times 0.5 is 0.125. So this is 0.125. To double check, you should do it with me. You should calculate it in your calculator to get the same result. For the second one, for my decimal looks, so this is just decimal. For the second one, 1 minus mu, 1 minus 0.5 is 0.5. Then square it. If you square it, you will get 0.25. 0.25 times probability of x. Probability of x is 0.5. So 0.25 times 0.5 is again 0.125. Do it in your calculator. I know it gets confusing when you hear it. When I say I'm plugging these values, rather you do it in your calculator and see if you get the same result or not. Now if you add 0.125 and 0.125, you will get 0.25. So your final result or the variance of this math is 0.25. So let's go back to the question in the end. Find the variance of x. So we got the variance of x. So that's it from point 4.17. We will do another math in the next video.